Okay, so in this part of the lesson, we're going to look at how we create histograms and when it makes sense to actually create histograms. Okay, so histograms are a really common graph, and you probably have seen several of them just through your everyday life. They're similar to bar graphs, except they're going to measure quantitative variables instead of categorical. And they're very useful, and they really are important when you have, sets of data where the values are very close to one another, like the heights of people or the weights of people, that sort of thing. So let's go over how we make one, and then we'll talk a little bit more about the concept. So we're going to break this into 3 steps. The first step is we're going to divide the data into classes of equal width. So what classes means are basically like interval lengths. So if you have heights that you're gonna make a histogram for, the heights go from like maybe 5 feet to 7 feet. Maybe you want to make the intervals like 4 inches. So you want to make sure every 4 inches, like 5 foot to 5'4", 5'4" to 5'8", like that sort of thing. Next, you're going to count how many of the total individuals are in each group or in each class. So how many are between 5 foot and 5'4", 5'4" and 5'8", and so forth. Now you can either use the actual count, the frequency, or the percent, the relative frequency, depending on what you want to do. And then you just need to label and scale your axes and draw the histogram appropriately. Okay, so let's go through an example because that always makes this easier to understand. So we're going to make a histogram for this set of data here. Here we have 60 values that show the distribution of IQ scores, and what's common is for people to think that the IQ scores follow a bell-shaped curve like this. Not saying it's not true. I'm not saying it is true, but let's see what happens. So here are the IQ scores of 60 5th grade students, and we're going to make a histogram and then describe what the histogram is telling us. So let's first figure out what classes or interval lengths we're going to break our histogram into. So let's look at the lowest and highest values we have here. So it seems, let's see, we have an 81 here. Oh, let's see if we have anything lower than 81. We have an 82. Nothing lower than 81, it seems. And the highest, let's see, we have 145. Then looks like to be our highest. So we want to make sure we can include values from 81 to 145. So to keep it simple, let's just go from 80 to 150. So let's go every 10. So on this axis, we're going to go, our IQ scores, 80 will be that value. 90 will be this. That'll be 100, 110, and so forth. 120, 130, 140, and 150. So here, let's label IQ scores. And then we're just going to make a frequency histogram. So we're just going to include the raw counts. So let's just, it looks like if we go by ones, we should have enough space. So let's just go by ones. So frequency on the vertical axis. Let's label it. Now, let's make sure we understand something important about histograms. Now, histograms can be what are called right-handed or left-handed. Now, what that means is that if a histogram is right-handed, that means that the number to the right is going to be in that in that class. So for example, it wouldn't make sense for this first class or for this, this first bar when we draw it to include both 80 and 90. It has to include either one or the other. So it either has to include 80 or 90. You can't include both. And usually it's going to include the 80 and not the 90. And I actually mean left hand. I should say left hand. Left hand histograms are usually the most common because we tend to write, left to right, at least, in the Western part of the world. So let me just make a little note. So this histogram would be like 80 let's put a bracket because we're going to include 80, but it doesn't include 90. So let me put a note actually. Includes 80, but not 90. And so then the next bar would include 90, but not 100. The next one would be 100, but not 110, and so forth. So let's go ahead and let's start constructing it so we can get a good sense of how this works. So let's see how many values are from 80 to less than 90. And we should get, let's see, 1, 2, and 3. So I'm going to put a 3 here just for now. We don't care about the exact values. We just care that they're from 80 to less than 90. Now let's see values from 90, but less than 100. So we include 90. So let's go. We should have 1, 2. So this 90 would go there. 3. And I think oh yeah, 4. They're 4. 94. So we're gonna have 4 in here. Then we go, how many are from 100 but less than 110? So we include 100 but not 110. So we go 1, 2, 3, 4, 5, 6, not the 110, 7, 8, 9, 10, 11, 12, 13. Let's make sure I didn't miss one. Oh yeah, and 14. We have 14 in here. Oops, 14 in there. Next one, 100, but less than 120. I'm sorry, 110, but less than 120. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Now 120 to 130, but we don't include 130, so we include 120, but we don't include 130. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's make sure I didn't miss one. Oh yeah, 11. So 11 in here. Now 130, but not 140. So 130 to less than 140. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That makes sense. And the last one, 140 up to 150. We don't include 150, and that should be the remaining. Looks like the remaining 2. Now I just drew the number there, just to kind of make sure we get a clear sense of what we're doing. So these numbers represent how many values are in those intervals. So we just draw a corresponding bar of that height. So the first one, we draw a height of 3. The next one would be a height of 4. Then the next one would be all the way to 14. And 17, so it looks like it could go a little higher, so we extend that. I'm gonna put a 17 on top there. Then 11. And then 9. And the last one, 2. And you don't have to shade it, but I usually like to shade it at least a little bit. Okay, so now let's talk about it a little bit. So it looks like it's somewhat symmetric. Again, no distribution is going to ever be perfectly symmetric, but it looks, roughly symmetric. It kind of does look like it peaks in the middle and it goes down. So maybe you could probably argue it is somewhat bell-shaped. And it looks like the average, or let's say typical IQ is, is somewhere in here, like 110 to 120. And they vary from 80 to 150 in the histogram, but in the real values, they go from 80. Well, the real values vary from 80 to 145, but the histogram shows values from 80 to 150. There doesn't seem to be really any obvious outliers. So let's go ahead. Let's basically write that down in a couple sentences. So the distribution. Appears to be roughly symmetric. We could say it's somewhat bell-shaped. Typical IQ is, seems to be from 110 to 120. And the IQs vary from 80 to 1. Well, let's say that's actually the actual value, 80 to 145. And there doesn't appear to be any obvious outliers. Any obvious outliers. Okay, so let's go over some of the principles that we need to keep in mind when we make a histogram. So since we're using histograms as a visual, our eyes are going to really respond to the area of the bars in the histogram. So make sure that you have all the intervals or classes to be the same width. Then you can just solely focus on the height since all the classes are fairly represented. Now there's no right choice of number of classes in a histogram. Too few will, give you a really a tall, steep skyscraper graph, and too many will tend to give you like a flat pancake graph. Like these are both bad choices. So a good rule of thumb is just to at least have five, but again, it depends on the data. Now let's think about what is it that we're actually doing when we make a histogram. So I went ahead and replotted the dot plot data from the number of shoes that my class, had. So let's think about this. If we want to make this into a histogram, what would we do? Well, essentially, what would happen is we would first break this into intervals. So let's say we want to go in intervals of 3. So we would go something like this. We would have our graph, this would be 0. Here, let's make it 3. Let's make this then 6, then 9, then 12, and then 15. So let's think about how this works. So we're going to put the total number of dots that are from 0 but less than 3 in here. Here there aren't any, so then we don't have to put any. Now in here we put the total number of dots that include 3, 4, and 5, but not 6. So it would basically just be these two. The next one would be dots above 6, 7, and 8, because remember 9 is going to go in the next one. So 6, 7, and 8, these guys. So we would have 1, 2, 3, 4, 5, 6, 7. And then here we would get the 9, 10, 11 group. So here we got 1, 2, 3, 4, 5. Then the 12, 13, 14, which is just this one, so just 1. And then 8, 15, 16, we actually keep on going to 18 in this case. And it would just be this last one here. And then we convert this into just bars, basically. So it would look something like this. We would have, again, 0 to 3, breaking it in 0, 3, 6, 9, 12, 15, 18. Here we would have 2. So we'd have a height of 2, let's say. This next one, we would have a 1, 2, 3, 4, 5, 6, 7. Something like that. So on to the next one, 9 to 12, 1, 2, 3, 4, 5. Then 12 to 15, we just got 1. And 15 to 18, we got just 1 again. So keep this in mind, because what you're really doing with the histogram is you're kind of just making a more compressed dot plot, but you're just not showing the individual values within each one. So you don't know how many, by looking at this, you don't know how many 3s, 4s, and 5s there are, or how many in this one, you don't know how many 6s, 7s, and 8s. So you can't be specific. So that's one disadvantage with the histogram that a dot plot has in this case. But a histogram is usually more efficient and gives you a easier way to look at the overall pattern, but not necessarily the little tiny individual values.